How's it going, everyone? Welcome, Eulia Gonzalez here. And today let's going to look now at the Model 2 of the course of the Joy of React to actually understand now what is working with state means. So, here we are. Just to make a quick recap of how do we get here. In the first model we were exploring about is what is React, what React came to light, and what is the problem that React was trying to solve or what solve, which is how you can manage is, which is a Facebook problem, how you can manage is an state and then you keeps that state sync across different user interface, right? So that's the core of React. And to reach to that point, which is what we're gonna see in today's video, we went through understand that React was developed internally by Facebook to actually solve this specific problem. And the reason why React has been so powerful in this particular mindset is so compelling is because not only it targets the browser but also its other environments such as the WebLG or the mobile development. So because this flexibility of any environments that use JavaScript, all right, uh, it is something that we are going to explore on how React actually create its own elements and how it works behind the scenes. And this is why in the first model we first look at how can we create our own React, which is a simple just JavaScript object that describe is the data about this HTML tag using now the create or the React or the create function, create element function, and how by passing certain arguments to that is going to generate now these objects which is being used internally by React to map this entire user elements. Now, because creating this user or this HTML tag is something that is verbose and lengthy and quite tedious to do, we have now, or the people in React actually developed these things called GSX, right? So GSX is this nice little way of, or this convenient way in which we can now write is HTML inside of our JavaScript, right? So we look and explore is, for example, what the GSX is, what the GSS actually works behind the scenes, and how can we look at the the transpilation phase. What is a transpiler? So in other words, what GSX is, uh, and how this is converted to JavaScript, and what is the similarity of this when it comes to convert it into this React stuff, all right? And also, how can we now is uh, explore the the syntax, the JavaScript, the GSX expressions. That at the end of the day, everything here is a JavaScript expression. We also look at the ECMAScript. What is in the JavaScript expressions? Whether it's a variable expressions or an assignment expression or an expressions, and these kind of expressions can be whether it's a function or async function. So, for example, we have this here, ECMA 2025. I do think it is, but this is pointing to identity, and we want to look is more at the grammar summary like this. So for example, expressions. So what is an expression? Okay, it can be an identifier reference or a binding or these primary identifiers, which can be a literal, or it can be array, a literal, or an object literal, or a function expression. Class is another one. We also can evaluate generator expressions, which is a generator function, async function expressions, async function generators, regular expressions, template literals, evaluating its expression inside of the parentheses, uh, and all this kind of stuff, right? What is an array literal? What is an element list? And all these kind of expressions that allow us to that is going to be evaluated inside of these curly braces, right? Which is the GSX expressions. And what is the difference between the GSX with HTML, which is it has a reserved keyword, so HTML tags are case sensitive, attribute as well, and how also look at the GSX versus the template engines, uh, and why GSX is quite useful and convenient unlike any other language or template engines, because well, you only have to know is JavaScript, period, right? So in that sense, as we move on to understand is the new way of creating this user interface, which is the idea of instead of defining everything as an HTML, CSS, and JavaScript per separate file, we have all of them into one single file. This component driven development. So we also look at the anatomy of this, the syntax, which is at the end of the day is a function, and also uh, what is the other part of the anatomy of a function or a component, which is the props and the children, and how these two are injected at runtime when your GSX is transpiled to a JavaScript, and therefore that code behind the scenes, the create elements behind the scenes actually automatically inject at runtime the uh, the the props as well as the children, or in other words is the content that is going to be rendered, right? The children's that component might have, all right, and the children is these collections of nodes, React elements nodes, that is going to be passed down as the uh, as these components, right? So in other words, it means that you must know in advance what children's are in order to pass down this, right? Because otherwise, it's like if you don't know the structure, if you don't know what children will be passed down, so there is no children to pass down. In other words, there is no content to pass down. And children is indeed is a particular property that is part of the HTML. And then how can we now is render elements, collections of elements without polluting the globals, the DOM, using the fragments. Sorry, my bad. And then how can we now iterate through our collections of values using is the map. For example, how can we by mapping elements here we can is now render is several collections of HTML elements, and how it is important for each one of them to have a key, so now React can uniquely identify this component or these collections of components that is going to be rendered, and how they cannot be is the index, because it causes problems when it comes to reorder and reshuffling and so on and so forth. Now, as we also look the iterations and how can we now is conditionally rendering elements here, and there are several strategy whether it's using is the if as an early return, which is great for early errors, or using is the and how the end you have to be very well aware of what the thing is doing, because it's going to return is the falsy value, whatever is on the left upper end, okay, uh, or it's gonna return is the evaluation of that falsy of that boolean value, right? And if that is a falsy value, it's gonna return you is, well, one of these falsy value lists. So the thing here is, because there's some caveat on doing that. So for example, with the number 0, we prefer to now evaluate that, to coerce that evaluation at the template to prevent any of these issues. So this is one. The other strategy is the conditional rendering, which is helpful for work as if and else statement. So for example, if you want to show something to the admins or to the users, this is how you can actually render this particular elements. And how now is going to evaluate that expression, that condition, and if that condition throw you at any of these falsy values, it's going to now throw you is whether it's the first or the second expression or assignment. So similar to the and or, which is act as a gate here, and say, hey, if this value is false, I'm not going to move on to the next one. And in fact, I'm going to return you that particularly falsy value. And I do think that's quite interesting. So for example, if we look at this, all right, and we examine here the logical operator. For example, the and here, like this. Exactly, runtime semantic evaluation. All right. What it say? Hey, if the left side is false, you're gonna return that value, right? You're gonna return whatever value it give you. But look at this. It's gonna return you is whatever value is gonna give it to you. If that evaluation is false, all right. So if that evaluation is false, all right, it's gonna return you that value. So in other words, it's gonna return you is any of these falsy values, whether it's null or whether it's undefined, right? But it's gonna return you that particular falsy value, not the coercion, not the coercion. It's gonna return you is the value of that. Okay, and of course that value must be any of these falsy values. All right. If not, then what it's gonna do is to if the ref is the right reference, be it the result of evaluating bit or expression, return the value of the left. So in other words, if I want to do something like this and say, hey, const name, right? And if for some reason I got is this, let's say this is now the last name. So I want to create is full name. So full name, let's say Gonzalez, and then the first name, right? And if the first name is indeed something like this, it's gonna now return you is this last value. So in other words, first name is not defined. I do think is this, then you got it. And the full name will be now is Gonzalez. But again, it's gonna return you is the last value of that. This is one of the reasons here why this particularly AND operator is useful when it comes to say, hey, the last value is some functionality that I want to return. All right. And we have to be careful with this. We have to be very careful of this. So because another thing is to say, hey, despite that I adding is this parenthesis to this, all right? Despite that I add this parenthesis to this, all right? That won't change the fact that the full name will be is de Gonzalez, as you can see. So this is the behavior of the N and OR operator, and why I hit the brake here a little bit to actually understand what this thing is doing. Okay? Because a lot of people say that this is going to be evaluating is one this expression and this another one, and no. This doesn't work that way. So and that's pretty mind blowing. And that's pretty mind blowing. Because this is binary wise operator and this is now binary logical operator. So I do think that that was quite interesting in terms of understand how the things actually truly works. All right. And yeah, you know, yeah. So the other is a ternary operator, as I mentioned before, which is this logical expression here, and it's going to behave somewhat the same, all right? And that's what you have to be careful about how the things actually works. Now, with that, the other alternative is to show and hide elements here. We can use is now, for example, CSS to doing that. And why, for example, as we make the exercise, how we use a particular components to guarantee the accessibility of a certain content, especially content that you want to show to users who can see versus those screen readers, and why this is important, and why do we actually need to create this special component that allow us to make it not visible to the users but for the screen readers, but true for the screen readers. Okay. So on that, okay, the thing here is, as we explore this and then how a convenient way to rendering series of collection using now range, and how now range is part of a silly function which is adding this, so giving a number, so giving a star and an n and the step, how you can actually is walk through this parameters and create this sequence of elements. And I do think that's quite interesting, very powerful, convenient, and the reason why also is now functional programming actually is something that is tremendous in terms of this specific problems that it needs to happen. So anytime that you need some computation and calculations, now functional programming provide now is a wide range of techniques to implement and to go with. So for example, high order functions, there's dynamic programming, sorry, as well as high order functions, dynamic programming, curring to actually transform the shape of the function, and there also, this is the only examples that comes to my mind right now. I already asked ChatGPT more about that. the JavaScript unique array creation. Okay. Which is hmm, functional as first class citizen. Exactly, it's this one. Right, create unique values in array dynamically. No, I do not. This is not. Let me, in fact, but I do think that I have this. Mm, hmm. Okay. Okay. Why functions as values are an important concept in JavaScript? I do know what is the answer, but I want to know the specifics of that answer. Okay, high order programming, event handlings and callback, dynamic functions assignment. Okay, closures and data privacy. Mm. Flexible API and configuration. I know there was another one. So, what are the patterns that we can use from functional programming? Exactly. For example, pure functions, immutability, high order functions, function composition as well, currying, partial application, monads, and maybe pattern, right? Recursion, of course, and function memoization, and the functor pattern. So, but the things that are quite familiar are the query function, and the other is a function composition, high order functions, immutability, and something that it doesn't mention here, but is the dynamic programming. For example, dynamic programming. Well, anyway, in any case, you went too far, bro. You went too far. But the thing here is that it unlocks that particular patterns, something that you're gonna get familiar with as you go with, and then the how do we put it? The the creation of this range and how can we use this range and how now despite that we know how to create, for example, it's called sequence of elements using the functional approach, how now clever code it is quite is detrimental. So clever code can and will be is detrimental because at the end of the day you are not writing code for yourself, you're writing is code for other people, code that are going to be shipped in production. And the more clear you are, the better off will be for any other, uh, including you from the future, to prevent to burn some extra calories and understand the intention in which the code was written. Then we also explore is how can we is styling components in CSS, using is the CSS models, and how CSS models is very particularly files that since we are following is this component driven development, we have now in React this CSS model that allow us to decide, hey, where we want to put our effort here. Okay, where do we want to define is this set of CSS rules, and once we do that, which one of them we want to get and making available in JavaScript, so we can now is pass the proper style to this at runtime. And all of this is something that is done by the tools of the trade, all right, which is Webpack. And how Webpack is, or Webpack, or Vite, or uh, TurboPack, where Turbo, Vite. So each one of those are aims to solve the same problem. So packaging JavaScript. Why this is important? Because in HTTP 1, to reduce the amount of requests that we need to make to our server, we first now transpile everything into a safe JavaScript code for browsers. Okay, browser safe JavaScript codes, and then now we bundle up, right? That can be ready for delivery. And since this is the particular process, and in HTTP2, despite that in theory it allows to send several dozens of HTTP or files per request, the reality is different, and there is now a um, yeah, so there's now um, an article from Khan Academy in their engineering blog, where they in 2015 they describing is how they went through actually is to put this theory at practice, and how now they didn't get any great result at the end of the day. And the deal there was, hey, because we want to now send several of those files, and because each one of those files actually now have imported several other files, these tree of dependency, the reality that sounds quite interesting, it turns out that it's detrimental when it needs to load dozens of files, where each one of those files has several imports that needs to be downloaded, in creating this cascading effect. All right, so that's why they decide to say, hey, we still prefer to go or to bundle up things, despite that catching is something that is quite not well, but at least it guarantees that we reduce the number of requests to hit the server. I do think that is quite compelling, quite interesting. So for a small application, you might go with the HTTP2, all right? But with bigger applications, it is up to you to evaluate how much of this is true. But in any case, the TLDR of this is that because Webpack, this model bundler that not only is providing its development, improving the developer experience, but also bundle up our code, bundle this browser safe code in this minifications and stuff like that. It is something that it will make the entire application much more straightforward, depend on the rendering mechanism you're gonna go with, whether it's client side or server side. So, but in any case, and here we are, okay? So, since CSS in models allows to define is several of these styles, where each one of these styles is also following is the CSS rules. So the order in which these styles are defined actually matter when you're gonna use inside of this React function. Uh, this is something that we explore and look in how can we do that. So I find that out very, very, very interesting, very, very compelling to do that kind of stuff. And then finally we are here working with states. All right. I'll be right back. And here we are. Here we are. Good. Good. All right. Let's get into this. Working with state. So in the early days of websites were essentially fancy documents, and we had load one HTML file, read the content, and then load another one. Okay. So the beautiful, amazing, magical thing about the modern web is that web applications are interactive. The app can respond to users' actions in real time without needing to fetch a whole new page. React has a really novel approach toward managing this interactivity. And once you get to use it, it is really hard to imagine managing in other way. In this model, we'll learn about how to respond to user actions with event binding. Why this is important to understand is the event propagation, how React manages the done for us, and what it actually means to re-render, which is calling this function. The user state hooks and how to use it to build interactive components, understanding the difference between props and a state. Working with forms in React, everyone's favorite topic, working with complex states like objects and arrays, and avoiding common pitfalls, for example, bugs related to state mutation, and how to share state across the application by lifting up. All of this something I am quite familiar with these three ones. All right. But not with this because my knowledge actually skip all of this. I also quite interested how I do know how this actually works, but I am more well aware of all of this. All right, I am definitely more well aware of all of this. This is really exciting model because we got from static website to dynamic and live applications, and let's do this. Event handlers. Before we look at the nuts and bolts of working with Stay in React, we need to speak a little bit about events. As the user interact with page, hundreds of events are fired off in response. The browser is like an invasive, private investigator tracking every little thing you do. Exactly. It's an invasive private investigator tracking every little thing you do. The following demo logs a bunch of different common events. Try interacting with this widget and notice the string of events that are subsequently logged. Okay. So trying with this interactive widget here. So this interactive widget is telling you what the browser exactly how the browsers actually is now tracking every little thing you do. So for example, mouse and even the button or this. And when you do click, you submit it, user form, you submit it. So you focus here and then do this. Mouse use hover over button 1. Mouse user finish clicking button. Submit. And then you have this. When you press down, user on focus button 1, user's focus button 2. Mouse release and all that kind of stuff. And also the scroll here. Even if keyword is tracking, exactly. Everything here. When we are building dynamic web application, these events become super important. We'll listen for this event and use them to trigger a state change. When the user clicks the X button, we dismiss the prompt. When the user submits the form, we show a loading spinner. Okay, in order to respond to an event, we need to listen for it. JavaScript provides a built-in way to do this with add event listener method. So you just get that button using query selector, all right? And then let the function do whatever it needs to be done. And then you're going to add that function when that click happens, right? So in this code, we're listening for a specific event clicks targeting a specific element's button here. And we have a function which is meant to handle this event. Do something. When the user click this particular button, like this. So when the user click this particular button, our handler function will be invoked, allowing us to do something in response. The web platforms offer another way to do this as well, and we can embed our handler right in the HTML. So React piggybacks, man. Piggybacks. Piggybacks, man. React's piggybacks. Holy crap, nigga. This is piggyback. I don't know how you say piggyback in Spanish. Como cargaditas. Algo por el estilo, ¿no? Como cargaditas así. Acuesta o caballito. Exacto. Piggyback. Caballito. Exactly. Piggyback. Okay. Piggybacking. Piggybacking, bro. Piggybacking. Okay. Piggybacking. Piggybacking. Okay. You know, we also learn vocabulary. React piggybacks on this pattern, allowing us to pass an event handler right in the JSX. Exactly. So here we're going to pass now this handler to the JSX. And with add event listener, this code will perform the same duty. When the user click the button, then do something, function will be called. This is the recommended way to handle events in React. Well, we do sometimes have to use the add event listener for window level events covered in Model 3. Okay. We should try to use the on X prop like on click and on chain whenever possible. While we do sometimes have to use add event listener for window level elements, we should try to use exactly for certain window level elements. Mhm. And there are a few good reasons why. Automatic cleanup. Whenever we add an event listener, we're also supposed to remove it when we are done with remove event listener. If we forget to do this, we'll introduce a memory leak, which happens when the application fails to release something from memory. As a result, the application continues to eat up more and more memory until eventually the browser tab crashes. So React automatically remove listener for us when we use on X handler functions. How do we know about this? So React automatically remove listener for us when we use on X handler function. So because on click is something that is going to be added as a props here, because I would like to also later on see how this thing is working and how this thing is doing. Okay. The other is improve performance. By giving React control over the event listener, it can optimize things for us, like batching multiple event listeners together to reduce memory consumption. So it batches several of these events to reduce memory consumption. So no DOM interactions. Reacts like for us to stay within the abstractions. React like for us stay within in abstractions. We generally try and avoid interacting with the DOM directly. In order to use that event listener, we have to look up the element with query selector. This is something we should avoid. And the happy path in React involves letting React do the DOM manipulation for us, staying within the abstraction. I want to expand on the last bullet point a bit because it gets something really important. One of the core ideas behind React is that it does the DOM manipulation for you. When using React, you shouldn't really be using query selector at all because this is part of the DOM manipulation. We want to stay within the React abstractions rather than trying to compete with it to manage the DOM. So when I first started learning React in 2015, my tool of choice was jQuery. If you're not familiar with jQuery, which is something that I am, it is a tool that makes it easy to select and modify the DOM. It is a DOM manipulation tool. Exactly, it is a DOM manipulation tool. I remember being frustrated that my tried and true conventions were certainly considered bad practice in React. Sometimes it seems much simpler to manage the DOM with jQuery rather than trying to figuring out how to do it with React. But honestly, though I set myself back with this mindset, I tried to bend React into a shape that was familiar to me. This is exactly when you're trying to use a tool that has a particular point of view, way of doing things, and you try to bend it. There's nothing wrong with that, but you're gonna lose all of the conventions and optimizations and benefit to go with. I tried to bend React into a shape that was familiar to me, but React just isn't that flexible. Once I finally learned how to do things properly, which is the reason why I'm actually looking at this, everything became so much simpler and easier. When learning a new technology, it is natural to try to bend or to squeeze into something that is familiar, into a familiar shape. But I promise you, you will have a much better time learning to swim with the current rather than trying to fighting against it. Different from HTML. When we look at unchanged props, because first we're describing is what is the event handlers, right? And different from the HTML. When we look at the unchanged props, it looks very similar to the in HTML methods of adding event handlers. There are some key differences though. We have camel casing. As we saw in the last model, we need to write camel case attribute name in GSX. Be careful to write on click, exactly as a camel case. Instead of on clicking, or instead of on click. Same thing with on change, on key down, on transition again, or any other event, right? Here's the good news. If you forget, the console warning left you about mistake with this. Warning, invalid element, invalid event handler properly on click. Did you mean on click? This common mistake tends to be pretty easy to spot. And let's take another common issue that unfortunately is harder to spot. Passing a function reference. When working with event handlers in React, we need to pass a reference to the function. This is another different from that. The camel casing, and because at the end of the day, all of these attributes that we are defining in our HTML elements are props, okay? They are props that are gonna be executed at runtime. So we are passing is reference. When working with event handlers in React, we need to pass a reference to the function. We don't call the function like we do in HTML. We want to do this, not this. When we include the parentheses, and this is something, remember that what happened is exactly, remember what happened here. Remember what happened here when this is converted. This is the create React element with the bottom tag followed by the property colon click, and you're gonna pass now a reference to that. When we include the parentheses, we invoke the function right away. And the moment the React application is rendering, the moment exactly, we are invoking that the moment the React application is rendering. And we don't want to do that. We want to give React a reference to the function so that the React can call the function whenever the user press on it, okay? When the user clicks on the button. In GSX is getting in the way. Here's the same code written in compiled JavaScript, which is this or is this. This will call immediately when the element is created, which is something that you don't want to do. Makes a lot of sense. So the difference from the HTML, camel casing and passing functions reference. Specifying arguments. Here's a conundrum, a confusing or a difficult problem or question for you. What if we wanted to specify arguments to this function? That's a good question. Exactly. How do you specify functions call? For example, let's suppose that our function is called setTheme, and we'll use it to change the user color theme from light mode to dark mode. In order for this to work, we need to supply the name of the theme we are switching to, like this. Exactly. So we want to provide is the value. If we pass setTheme as a reference on click, we can supply arguments, right? But in order to specify arguments, we need to wrap in parentheses, but then it gets called right away. So so that's what we pass here as an arrow function. We can solve this problem with a wrapper function. Hey, this will be the reference that are gonna be passed to the onClick. And I'm passing here is the reference. I'm passing here is this arrow expression, is this function expression. We are creating is a brand new anonymous arrow functions for this and passing it to React. When the user click the button, the function will run and the code inside the function is executed. Exactly. But this is when you want to pass now arguments to a function. Mhm. If you're not super comfortable with arrow function, be sure to check the out. Be sure to check out the arrow function primer lessons. If it is still confusion, there is no need to worry. This pattern is very common in React, and there will be an ample opportunity in this course for you to become familiar and comfortable with it. But this is the difference of this. So the root of all problem is not in the solution, is on the problem in itself. So yes, um, if it so bad performance. You may have heard that creating arrow functions, anonymous functions like this, is bad performance. So bad performance in terms of what? There's a lot of misinformation out there around this topic, and it's frustrating to me because it makes developers worry about things that really don't need to be worried about, and they worry because they don't know, they don't want to understand why they're worried about. They just want to get worried. There is no seriousness in doing this. To quickly summarize, there isn't a measurable performance difference between creating anonymous function versus name function. Same thing for arrow versus traditional functions. The cost of creating a new function is extremely low. Even low-end devices can create hundreds of thousands of functions in a span of a human blink. React has a built-in event delegation system that implements a bunch of optimizations for us. Which one of them, for example? So React has a built-in delegation system that implements a bunch of optimizations for us. Like, like what? Like which one, bro? It's like what? Trust me, bro. Um, so given the following sentence, okay, what will be the optim op, optimization? What will be the optimizations? React Event Delegation System includes several key optimizations. Single event listener strategy. A single event listener strategy. Instead of attaching individual event listener to each DOM element, React attaches a single event listener to the document root or React root in React 17 or plus. So React attaches a single event listener to the document root. This dramatically reduces memory use and setup overheat, especially in application with many interactive elements. Why doing this reduce dramatically the memory use here? Single event listener strategy, event pooling. In older versions, React used the pool synthetic event objects to reduce garbage collection pressures. Though this was removed in React 17, it was a significant performance optimization for years. Synthetic event wrapper. React wraps native DOM events in synthetic events. Synthetic event wrappers. Okay, React wraps native DOM events in synthetic event objects that provide cross-browser compatibility automatically. Okay, so anytime that you detect a native DOM event, it's gonna wrap into this. Okay, it's for to make their life much more simpler. This eliminates the need for developers to handle browser-specific event quirks and ensure consistency behavior across different browsers. Holy moly. Okay. Okay. So you don't have with React. So with React, you don't have to worry about is this different way of manipulating is event native DOM events. Automatic event bubbling handling. React's delegation system leverage the natural event bubbling mechanism. When an event occurs on a child element, it bubbles up to the React root listener, which then determines the appropriate React component handler to call on the event page. So, so instead of creating is a one, so instead of creating is all of this event listener per HTML tags or components, it in fact create now a root event listener, all right, that is going to handle all of them. Efficient event dispatching. This is automatic event bubbling handling. React delegation system leverages the natural event bubbling mechanism when an event occurs on a child element. It bubble up the React root listener, which then determine the appropriate React components handlers to call based on the event target. Let's see event handler registration. React only register native events listener when components actually need them. Okay. React only register native event listener when components actually need it. If no React components are listening for a particular event type, React doesn't set up a listener for it at all. Efficient event dispatching. React batches and optimize the process of calling multiple event handlers during a single event cycle. Okay. React batches and optimize the process of calling multiple times, reducing the overhead of multiple function calls. Memory management. Since there is typically only one listener per event type at the document level, Reacts avoid memory leaks that could occur from forgotten event listener. Since there are typically only one listener per event type. Okay, since there's typically one listener per event type at a document level. Okay, so at a document level you have one listener per event. Reacts avoid memory leaks that could occur from forgotten event listener, cleaning up in traditionally done manipulations. Okay, because it centralized is the event at a root level per type. Let's go. Let's keep moving. Let's keep moving. Now there is a kernel of truth to concern around functions in React, but React gives us a tool to manage them. It is called useCallback, and we'll learn about it in Model 3. If you want to now there is a kernel of truth to these concerns around functions in React, but React gave us a tool to manage them. It is called useReact, and we'll learn about it in the Model 3, especially when you want to avoid to compute something. Okay, when React is evaluating now the React function and you want to avoid to compute something, yes, you say, hey, I want you to avoid to compute this. When you're evaluating this, if you find this directive, skip it. So if you're evaluating this statement with useCallback, skip it. Skip it only if the props hasn't changed. What about the .bind? There is another way we could have solved this problem, especially of the specifying. So I'm well aware of this approach, but the another approach is with bind. Okay, what you want to pass is the arguments to that. While this method works just fine, it is much less conventional in the React community, and there is no clear advantage. I suggest using anonymous wrapper functions instead. The exception is if you actually need to specify a context value for this, but this is very, very, very rare in React applications. Okay. Mm-hmm. Mm-hmm. And then we have now the exercise. Click the ball. Let's build a simple game. In the playground below, a ball moves around randomly. The goal of the game is to click the ball. We want to click the ball. We want to show an alert when the ball is successfully clicked. We can use window.alert to show the message. Accepting criteria. When the user clicks the ball, a winning message should be shown. You should handle click event specifically, as this event is triggered on click, on tap, or even when the user focuses the element with the keyword and hits the enter. If you don't use a pointer device, you can use keyword method to test your code. Note, if you find the ball movement distracting, you can disable it, pop over the CSS, and tap the comments. Okay. This is interesting that it's using this recurring component here. Hey, this is ball, right? And ball here is using the class name called ball. All right, called ball. As it is. This style is something that is global. It's not per component. So this is the ball. At the end of the day, it is a box that is being exactly. As you can see, it's a box that is being moving here. We have also another element like this, which is the same position, right? I do want to know how this will look like. Mm-hmm. Oh, it's like having a content here. Mm-hmm. It's like to target that element inside of this. Exactly. It's like having the ability to target that element here. Exactly, it's like having the ability to target that element there. Animation that move the ball randomly across here. Mm-hmm. Prefers reduced motions, no preference. Mm-hmm. So here you say when the user click the ball, a winning message should be shown. When you should handle click events specifically as this event is triggered on click, on tap, on even when the user focus the element with the keyword hits the enter. When the user focus the element with the keyword and hits the enter. Okay. Mm-hmm. And hits the enter. Mm-hmm. So we want us to add this particularly function here to say, hey, I want to define here as a function to say handle click, where this will be now a function, all right, that it will accept is no arguments right now, but we could, all right, and say, hey, console or alert window dot alert, and then do things like this. You win. So you win. Since here we want us to handle not only is um, winning, okay, or winner, okay. Since here you want us to cover is this function for several events, it makes a lot of sense to say, hey, on click, I want to now is pass this as a reference. I am not going to pass any argument here. And the same for on keyword on keyword focus. Exactly, the focus event, or on focus you say winner. Oh, and they stay there. Oh, okay, yeah, we get it. On keyboard enter, exactly. on keyword event which is on key down in our case. On key down, so we can say is this. So we say on handle or handle click. All right, so you win. Right, and the other is handle handle key down. Right, so here you're gonna receive is that, and so once you focus, okay, so once you focus, and by the time that you focus that, we want to know what is the console log event here on the unfocus. So we reload this, and then we focus here. So we got now is this huge object that we're getting here on focus. But the reality is that we do want to, because it's this, you should handle click event specifically at this event is triggered on click on tap, and even when the user focuses the element with the keyword and hits the enter key. But as you can see, React is actually wrapping that into this huge object. Okay. So the thing here is that we're not going to handle this on focus. In fact, we're going to do this on key down. That's what we want to handle this. On key down, I do want to know this. And then you win. But I do want to know is what is this? Because this is on key down, and if this is and if this is now the return keyword, even though now here is given to you this abstract operation here, what it's doing is that for you, because on keyword events you're gonna receive this type here, whether it's the key down, key up, in key press, followed by their options. Followed by their options, which mean is this. and this detailing which init target, things like that. And if this, so if the target is this, so in this object, do we have is the options? Yeah, do we have is the option here? Char code, key code, which no, I do not have that. Interesting. Current target, event phase, bubble, cancel. Is trusted. But we can have access to the key here. And if the key so if key is equal to whether it's a key code or char, is equal to enter, okay, then I want to say alert. Let's say window dot alert, you win. Right, that'll be all. So if we're able to focus that element and then hit enter, it's a you win. But now it is triggering twice, and I don't want to trigger twice. So it's things that is on click is actually calling, is triggering that.
So I don't know about you, but I find this motion really distracting when I'm trying to work. So the first thing I'm going to do is go into the CSS file and comment out this animation so that the ball stays in one place. With that done, I'm going to create a function called handleClick. And when I click on the ball, I want to call window.alert with the text you win. Now, to wire it up so that this code executes when the user clicks on the ball, I'm going to copy the function name and pass it to the button under the onClick property. When I do this, if I try clicking the ball, I see that I get a nice little message telling me that I've won, and it only happens when I click on this specific button. I can click all around it and nothing happens. Now, the most common mistake here is to add the parentheses after the handle click. You see, when I do that, I get the alert right away, and in fact, the moment the page loads, even before it's drawn the ball, we get our alert. This is happening because when the page loads, it runs through all of this code, and it sees that we're not only mentioning the function, but we're invoking it. And so in effect, what this is doing is it's calling the function, and it's passing the alert over here. But it does all of this immediately when the page loads, rather than giving React some instructions to do later when the click event happens. So this is probably how I would solve this, but there's another way that some of you may have thought, and that's to use an inline function instead. And so rather than have a function up here that I pass as a reference, why not create an inline function that does the exact same work, something like this? And honestly, both of these approaches work equally well. They both get the job done. The only thing I would say is that when you use an inline function like this, It's fine if there's only one expression, like if it's only doing a single thing. But in a real situation, it's common that these functions are handling lots and lots of different things, and so you wind up with many, many different statements. And I prefer not to have that in my JSX, because I want to see what the markup is when I look down here, and if I have this multi-line function, it makes it harder to see what the markup is. But yeah, in this case, where I'm only doing a single thing, I honestly think both approaches are equally valid.
Well, this is interesting. It is triggering is twice here. So I do not need to do this, and in fact, only this as it is. Let's make our game a bit more interesting. In addition to ball, is now feature a bomb. If the bomb is clicked, we want to show loose. Below you will find most complete implementation, but there is a problem. Clicking either item, bomb, or ball shows the loose message. Your mission is to fix the code below so that it shows the right message depending on which item is clicked. So accepting criteria. When the user clicks the ball, a winning message should be shown. When the user clicks the bomb, a losing message should be shown. The handle click function should still be used, and you shouldn't have to change anything about the function in itself. And exactly, this is the ball, and this is the bomb. So this animation is gonna get triggered, right? But you do need to actually pass a function here. You need to pass argument here, and the way best so you can do is something with this, like bind, okay, where the context is something that you might want to pass here, and then the arguments here. We usually don't do that. In fact, we prefer is going with passing as an arrow function to this, and by the time that we need it, we say, hey, this will be when. All right. And the other is this. So by the time that we now pass this, we say false. All right. So good. So good. Good. Great. 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 So now that we run here and then we click, for example, here, you say you win. And when we click now the bomb, you say you lose. And you say that properly. So this is just to see how you can work with parameters and what's going on behind the scenes with this kind of
So once again, step one is going to be to comment out the CSS responsible for the bounciness of these two entities. As much as it makes the game kind of pointlessly easy, I just can't handle the bounciness in my peripheral vision. Looking at the code, it's pretty similar to before. I still have a button that has an onClick property set to a handleClick function. I do have a second button now that shows this bomb emoji. But the big difference now is that my handleClick function has a type parameter, and based on the value of the type, I either show the win message or the lose message. Now the problem here, the reason I see the lose message in both cases, even when I click on the ball, is that I haven't specified that the type should be equal to win when I click the first button, and should not be equal to win, should be equal to the string lose when I click the second. React has no way of knowing that that's like my intention in this case. I have to be the one that specifies it. And the most intuitive way to specify that would be to add some parens and the string win. But like we saw in the previous exercise, when I do that, it means that I am invoking this function immediately, right? I have to action like. And React doesn't know what's in this function, right? This is sort of a mystery to within React when the click event happens. Of code right over here. I do know that it can be a little bit mind-bending. It took me a while to really feel comfortable with this pattern. But it is, I think, the best way to solve this problem, and it does allow us
So
to
what it's
pass
doing is just
custom
passing now a
values to the
reference
same function
message
in
into this
situations like this. And so now,
whole
when I click on the
object
ball, I get the win message. If I
of
click on the
the
bomb, I see
props
the lose message.
of this React element. And show more. So we need to pass the lose argument? Several students have pointed out that the type isn't strictly necessary for the bomb bottom. Instead of doing this, you can just call it it is. Or handle function, after all, only checks for win if it doesn't check for lose. But you can, but just because we can omit the argument, should we? Here's a question for you. In this new version of the code, what do you suppose type will be assigned to within the handle click function? Exactly. It is quite hard to understand what it is. What will this log when the when we click the okay, this is undefined because we are not passing any arguments to this. The type argument does not exist, so we're not receiving any arguments into this function, so therefore it's undefined as it is. Right, since we're giving it a value, actually it'll be a synthetic base event object. Oh, holy hell. So you are now receiving is this as a synthetic object here. Okay. This happened because React is the one calling or handle click functions for us. When the button is so when the button is clicked, it provides this gnarly event object, which contains a bunch of metadata about the click that just occurred. We'll learn more about the event shortly, but for now, though, let's consider our choice for how to structure our code. We can choose between a type parameter that will either be win or lose, but this synthetic base event is something that is injected by React, similar for the props and the children here. Makes a lot of sense, man. Makes a lot of sense here. Makes a lot of sense here. Makes a lot of sense here. Mm-hmm. 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 That makes a lot of sense here is because interesting. So anytime that you see things that are not the normal way of how the things work, You need to understand what's going on first. And second is that React is something behind the scenes doing this. Makes a lot of sense. Makes a lot of sense. So a type parameter that will be either be win or lose, and a type parameter that will be either be win or synthetic base events. It is important to remember that we are not only writing code for the computer, we're also writing code for other humans and for our future self. It's not sufficient for the code to work. I also want it to be consistent, unsurprising, and semantically intelligibly. It's because if you don't pass any arguments to this, React by default is injecting that. React by default is injecting that. And then the useState hook. Let's start by looking at a common example, a minimal counter demo. Click the button and watch the counter increase. And there you got it. You define is now the useState hook. Pretty straightforward, you know. So what it's doing here, what's going on, there is a lot going on here, so let's break it down. So what's going on here is that anytime we set this function behind the scenes, this arrow function that was assigned to this onClick property inside of this React component or React element that say, hey, I'm going to now detect when an event happens and now run this, particularly this, and now run this or execute this expression, this arrow functions. So this arrow function, which contains the set count like this, what the set count is doing. So since here we are receiving is the value and the function, and this is now a function that is given to us by the library in itself. It now, when it calls these functions, not only is going to, in this case, update the value, but the way how this is doing is by calling this state or calling this function with this argument, and then internally now is giving you a update value here. And this giving up you this internal value of the count is something that is quite mind bending and things that we're gonna see in today's video. So our goal is to keep track of the number of times the user has clicked the button. Whenever we have dynamic values like this, oh, so it's time, so it's like you have now internally some sort of map where you have is the count and the function that is going to update that. Followed by the value, the name of the value, as well as the value. So you have now the name of the value as a key and the function that is going to be updated. Okay. Whenever we have dynamic values like this, we need to use React state. So state is used for values that change over time. To create a state variable, we use the useState function. These functions take a single argument, the initial value. In this case, that value initialized to 0. And this value is chosen because when the page is first load, we have clicked the button 0 times. useState is a hook, and a hook is a special type of functions that allow us to hook into React internals. And we learn much more about hooks later in this course. But the useState hooks returns an array containing 2 items, which is the current value of the state that we decide to call it count, and a function that can use to update the state variable. Right? This is known as tuple. Destructuring assignment. If you're not familiar with array destructuring, this syntax might look a little wild to you. To help you understand what's going on here, the same logic but expressed without using the structuring assignment. So we had count array like this and this one. You can learn more about array destructuring from the JavaScript primer as it is. But here we're talking about is the useState and naming conventions. When we create a state variable, we can name the 2 variables whatever we want. For example, this is equality value. We have hello, we have word. But in our case, this is a particular convention to set the value as it is. So the first destructuring variable is the name of the things we have tracking. The second value prefixes the name with set, signifying that this is a function that can be called to change the things, and this is sometimes referred to as a setter function, since it sets the new value of the state variable, importing the hook. Some React tutorials write this sort of code in a slightly different way, and you have things like this. Instead of writing react.useState, we are importing the useState function at the top of the file and using it in its own. Here's the bottom line. These methods are completely equivalent and either one works just fine. Personally, I don't want to have the fuss with imports. It is a teeny distraction to me, and I'd rather write a few extra characters every time, but this is 100% personal preference, and you can manage it however you wish. In the initial value. So React states variables can be given an initial value, something that I'm quite familiar with. You can also supply a function. In React, we'll call these functions on the very first render to calculate the initial value, as you see here. So you're gonna call this on the initial render, or the initial evaluation of all of your components, to create all of those hooks and manage the DOM for us. And then you have console.log count is equal to 2 as it is. This is sometimes called as initializer function. It can occasionally be useful if we need to do an expensive operations to calculate the initial value. For example, reading from local storage. Mhm. Hey, I want to reading for local storage. Get get item, save count. If you're not familiar with the local storage API, it is a way for us to save values on the user device so it persists even after the browser tab is closed and can be accessed on their next visit. The benefit here is that we are only doing the expensive work reading from local store once on the initial render rather than doing it on every single render. And we'll see a full example of how to persist React state to local storage later in this course. And I do think this is a model 3. Exactly. Hang on a second. What? Several students has wondered why this secondary form makes a difference. Aren't we only calculating it once in either case? What is exactly the difference between the two forms? Whether if you're calling that function here and you're passing this as a parameter, okay, or your passing is now a function here. Again, and the thing here is because how the thing is being calling behind the scenes. I think this is pretty one of those cases where it is helpful to forget all about React and to think this is plain old JavaScript. Here you are passing here as a reference. Here you're passing this. Here you are running this once. Alright? Here you're saying, hey, I want you to give me the value, and this value is going to be passed down to the state. Whereas here you're saying is, hey, I want to give pass you now a function, and then somehow you, React, will going to call the function when you see fit. I think this is one of those cases. Let's say we have this function. Whenever I call run function, we log the console, we log the word hello. If I call the function 5 times, I get 5 times hello in the console. Now supposed to tweak and say hi. And you say this. Now when I call the run function, nothing is logged to the console. That is because the console log is packed up in an inner function say hi. Every time we call run function, we are creating a brand new say hi functions, but we're never calling but we are never calling it. Alright, now let's look at the React code again, which is pretty much what happened here. So what you're doing here is to say, hey, call this function, and the value of this function, there will be this parameter that you're gonna pass down to. Whenever we render the counter component, these functions will be called, and all the code inside will run. All this statement inside of this code will run. We'll call window.local storage on every single render. Okay. And pass the value into React useStates. Now let's consider the secondary form, which is this. We are creating is a function, and this is not going to be executed every time we render this component. And this is why this is part of the optimizations techniques here. We're not gonna call these functions on every render. In this case, we're creating a function here, and this function is being passed into a React.useState. And so it is up to React to decide what to do with it. Exactly. Hey React, this is the set of instructions. This is the reference of the set of instructions. And it is up to you to decide when to run this, right? So on the very first render, React will call this function to calculate the initial value. On subsequent render, however, React ignores the function. The initial values has already been calculated, And so there is no reason to call the function again. I recognize that this stuff is complicated, especially if you are not already super comfortable with JavaScript. Fortunately, this isn't something you need to understand right now, and then suspect it'll click for you as you get more experience working with functions in JavaScript. But it makes a lot of sense. How do we make sure how do we make sure that this is the way how it works? Let's move on. Let's move on. So, we got a particular question. How do we make sure that that's what happened? Okay. So we have seen that when we update a state variable by calling the setter function setCount, the UI gets updated. But how does it work exactly? This question cuts straightforward to the core of React. The library, after all, is literally named for how it reacts to state change. This is a question we're going to keep coming back to throughout this course as we build our mental model for how React works. But again, according to the React Dev docs, it passed through a series of steps. So the first is the initial rendering or the triggering, where all of its functions are being called, and then so it passed through the trigger. All of its functions are being called, and then the rendering. This is when the function is executed, and if this function has nested functions, aka if this function, this component, has more nested React components, it will continue to call all of them until there is no more elements to call. And that is HTML tags. And it makes a lot of sense. So this will slowly closing the gap of this. And ultimately, once that is done, once it runs all of those functions, and only run those functions when they're changed state, all right? Because React internally must have a hash table to say, hey, we're going to keep track of all of this, and somehow we're going to detect, hey, do we need to run this? Is this component actually is needed to be executed or not? And then lastly, once all of that is being done, it's going to evaluate is the hooks or the custom hooks. This question cuts straightforward to the core of React. The library, after all, is literally named for that. This is a question where we're going to keep coming back to throughout this course as we build our mental model for how React works. But let's see if we can start answering it. Let's keep working with our counter examples. So for example, like this. Exactly. So a bit of review. Let's talk what happened when this component is rendered for the first time. Our content functions return, so when this is evaluated to a React element, when this is transpiled, our content functions returns a bunch of GSX. And let's write in a pure JavaScript so we can see what's really going in here. So all of this is creating is a React component with this props, all right? The value as well as the children, okay, which is count, all right? And when this code runs, React create elements produce a React element. Exactly, produce a React element which is a plain JavaScript object. Okay, it looks something like this. So you have the type, you have the key, the ref, the props, also with the children's value. value 0. Exactly. As we learned in the last model, React elements are essentially description of the UI we want. Exactly. React elements are essentially description of the UI that we want. We are saying in this case that we want a button that contains the text value 0. We could visualize this JavaScript object as the following HTML snippet, like this. Our React element that JavaScript object is describing this DOM structure. React takes the description and turns it into a real thing, and it creates the HTML element with the DOM node and appends to the page. It didn't show the onClick handler in this little sketch. I didn't show the onClick handler in this little sketch, but it's very much part of the process. When React creates and inject the button to the DOM node, and it creates our handler function. Now let's think about what happened when this button is called. So when this button is called, what it's gonna do is calling this function. Okay. So React needs to identify which component trigger that state. Okay. The set count function will be called and will pass in new value. Count will be increment from 0 to 1. Whenever a state variable is updated, it triggers a re-render. Once again, React will call the counter function, and this creates a brand new React element, a new description of the UI we want. Anytime we now create this anytime that the element is getting anytime that we update the state or it triggers a re-render, what it's going to do behind the scenes is to create a new description of the UI we want in a form of an object. That this object has is the type, the key, the props, the children, as well as other props here like store and owner. Okay, and the ref. And the ref as well. So this is the description of this object. Say, hey, this is the type, this is the key, this is the ref, this is the props, as well as it is children. Okay. And this is all private methods here, owner and store, and so on and so forth. Whenever a state variable is updated, it triggers a re-render. Once again, React will call the counter function, and this creates a brand new React element, a new description of the UI we want. The new React element describes this DOM structure. I'm showing it here as a HTML since it is easy to demonstrate, but really, React deals with JavaScript objects that describe this markdown. Each render is like taking a snapshot. We generate a description that shows what the UI should look like based on the component's prop states. Exactly. Hey, this is the snapshot of this UI based on the components on the prop state. And it is like a photo that captures what things were like at the moment in time. And so React has two snapshots. Exactly. And so React has two snapshots. The user clicked the button and this second snapshot was generated. Exactly. It's generating the second snapshot, second description, a second object of the UI. Now things becoming more tangible, becoming more real. Because when I'm trying to describe this, also I have the image here. Okay, is the image here. hmm So you know those games where you show the two slightly different image and you have the spot the difference, right? For example, this one. So the granny actually is getting this, having a different thing here. Even the the picture here of this drawing here is different. The same for the knobs here. So far one, two, three, four different. Uh, the smile, five, seven here in this position. Uh, 8. There's a difference in this plate. Even though there is a difference in this candy, 7. But there is 8 difference here. There's another one. 9 different. So but you get the idea. You get the idea of the spot the difference here. And React essentially has to play this sort of game, hunting for changes between the two snapshots. And this process is known as reconciliation. So the process of taking two snapshots and figuring out the difference to create the proper DOM element and attach that to the DOM is known as reconciliation. Using fancy optimized algorithm, React figuring out what changed. It sees that the bottom text content has changed from value 0 to value 1. Once React has solved the puzzle and work out what's different, it will need to commit this change, which is the commit phase. Exactly. So you have the trigger, the rendering, and once it knows the difference, once it rendered to all of those functions, it call all of those functions, and each one of those functions produce this object, this description of the UI. Okay, and once React see this, and once React have these two snapshot, the older and the new one, it's going to find the difference and spot that. Okay, it's going to find the difference and spot that, and this process of finding or spot the difference is known as the reconciliation. And this is something that happened is in the rendering to commit phase, between the rendering and the to commit phase. So the process of the process of understanding the difference between the two snapshots. So the process of understanding or to spot, the process of spotting the difference between the two snapshots in React is known as the reconciliation, and it happens exactly, and it happens before, okay, and it happens before the commit phase. and it happens uh, right after the render phase render phase and before the commit phase. The reconciliation process in React actually happens during the render phase. Okay, no, okay. Mm-hmm. Mm-hmm. Okay, happens during the rendering phase. React compares the div, the new virtual DOM tree, with the previous virtual DOM. Okay, that's why we have this virtual DOMs here. Okay. And they counted as this virtual DOM. Mm-hmm. Okay, because once it's rendered at once, it creates this huge massive object. And once it detects some state change, alright, by holding that state, alright, it's going to now trigger that rendering function. It's going to trigger, it's going to rendering, it's going to call in that function. I prefer the term render to get myself familiar. It's going to rendering the, because I, what? Who are you talking to? I'm talking to myself. Exactly. Like you're talking to somebody else. No, 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 you're talking to yourself. It's rendering. So is then is so once the component is loaded, alright, which is a JavaScript function, and on the initial call, it's gonna call all of these components and render all of these elements here. Okay, it's gonna create all of these elements and React is gonna create a proper DOM behind the scenes. Creating is the proper elements and then attached it to the DOM. Okay. When an state change here, when that happened, is because now that React detect that change somehow, okay, and this is when an event happens. This is the mechanism of how React detect an state change. It detect that state and knows the component that triggered that, and then it's gonna trigger that. It detect that triggering phase, then it's gonna call that component, alright, which is known as the rendering phase. And during the rendering phase, when it calls that component, which returns now is an object, alright, with this new particularly description of this UI element, is going to continuously call all of the other nested functions that live inside of this. So until there is no more React elements. But in the meantime, if there are any component that say, hey, I don't want to be called, I don't want to be rendering here, and the signal to do that is by saying memo, okay? So I want you to memoize this component. So React, hey, please save somehow the state of this component, and only when this prop change, I want you to call that. It's gonna evaluate that and say, hey, no, this is memo, but we're gonna skip that, and so on and so forth. So during this evaluation, the the spotting difference here is happening in the rendering function and also the conciliation. So when that rendering phase happens, all right, now it's time to commit those changes because I already know what is be the end state of the app, and then I'm going to is commit that to the change. So I already have the current snapshot JavaScript, huge, massive JavaScript object, and then well, React is going to commit those changes, but it's smart enough to detect which one of them needs to be applied. Not all of them, which one of them. Holy French dogs. Oh my god. Mm-hmm. This phase is interruptible and can be paused and resumed. Interesting. Very, 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 very interesting. Okay. So this process is known as reconciliation, and using fancy optimized algorithm, React figuring out what's changed. It sees that the bottom text content has changed from value 0 and 1, and once React has solved the puzzle and worked out what's different, it will need to commit this change. With surgical precision, it updates the DOM, taking care to only tweak the things that needs to be tweaked. In this case, the operation will be something like bottom.inner text value 1. This is the fundamental flow of React, the core loop, and we can visualize this sequence. Once the component is mounted, it's gonna call the entire components. Okay, when the okay, so when the component is mounted, when we render the component for the first time, and there is no previous snapshot to compare to. Exactly. There is no previous snapshot to compare to, only the first one. And so React will create all the necessary DOM nodes from scratch and inject them into the page. When it detects a change, which is via setting a state, eventually something happens that triggers a state change, invoking the setX function. So set counts, and we're telling React that the value of a state variable has just been updated. So this trigger now is when React detects that change. Because a state change, we need to generate a new description of the UI. React will involve our component function again, producing a new set of React elements. Exactly. With this new snapshot in hand, and React element is this JSON object like. So with this new snapshot in hand, React will reconciliate that, comparing it to the previous snapshot and figuring out what needs to happen in order for the DOM to match these latest snapshots. And when it knows what were those changes, okay, if any DOM updates are required, React will perform those mutations, changing the text content of the DOM node, creating new nodes, deleting remove node, and etc. Once the change has been committed, React goes idle and wait for the next trigger, the next state change. Now you can click the boxes and explore each of the 4 stages described above. This is the core React loop. And then now the difference between rendering versus painting. So in this core, each model started with a custom 3D illustration. You might remember seeing these complex machines from the initial lesson in this model. I create this illustration using 3D modeling software called Blender. Interesting. In Blender, I can render my project to create a final image. Wow, it renders pretty fast, bro. This recording is speed up 150x time. It is not actually that quick. Oh, okay. Mm-hmm. Okay. And this is layer 21. 45, 73, 129. The term renders generally refers to this sort of things. We're talking some sort of unprocessed raw inputs and generating a final ready to use output. Even in web framework, this definition is pretty consistent. In Express, for example, a request ends when we render an HTML template. Exactly. Hey, I want to render this and this. In React, however, the term render means something slightly different, which is running the function. I think so much confusion in React stems from this misunderstanding. Let's take a look at an example. Suppose I have the following component. Our age limit component checks an age props and returns one of the two parameters. Paragraph. Now let's suppose we re-render this component and we end up with the following before after pair of snapshot. So we have age 16. This is what it's going to return. This is what you're going to return. 17. In both cases is less than 18. So we end up with the exact same UI. As a result, no DOM mutations happen at all. So when we talk about re-rendering a component, we aren't necessarily saying that anything will change in the DOM. We're saying that React is going to check if everything changed. Exactly, re-rendering or checking if React or checking if something changed. If React spot a difference between snapshot, it'll need to update the DOM, but it will be a precisely targeted minimal change. Exactly, it's not as a chirurgical procedure. When React does change a part of the DOM, the browser will need to repaint. Exactly. When React does change a part of the DOM, the browser will need to repaint. A repaint is when the pixel on the screens are drawn because a part of the DOM was mutated. This is done natively by the browser when the DOM is edited with JavaScript, whether by React, Angular, jQuery, Vanilla JavaScript, anything. To summarize, a re-render is a React process when it's figuring out what needs to change, aka reconciliation. The spot the difference gain. If something has changed between the two snapshots, React will commit those changes by editing the DOM so that it matches the latest snapshot. Whenever a DOM node is edited, the browser will repaint. Whenever a DOM node is edited, the browser will repaint, redrawing the relevant pixels so that the user sees the correct UI. Not all re-renders quite repaint. If nothing has changed between snapshot, React won't edit any DOM nodes, and nothing will be repainted. Exactly, not all re-renders requires repaint. If the snapshot remains the same, if nothing has changed between the snapshot, React won't edit the DOM node and nothing will be repainted. The critical thing to understand is that when we talk about re-rendering, we are not saying that we will throw away the current UI and rebuild everything from scratch. No. So React tries to, exactly, which is explaining is the specific phase here, render and commit phase, which is what's going on here. Unfortunately, this won't paint this. So, for example, if you say something like this, let me see. And here it's telling you that during the initial render, React will create the DOM nodes, which is the mount phase. And during a re-render, React will calculate which of the property, if any, have changed since the previous render, and it won't do anything with that information until the next step, the commit phase. So if anything has changed, good. I won't do anything here right now. I'll do that in the next phase, in the commit phase. Step 3, React commit changes to the DOM. And this is how it actually is doing this. So after rendering calling your component, React will modify the DOM. For the initial render, React will use the append, exactly. For the initial render, React is going to now use the append child, all right, which is creating the entire DOM nodes on the screen. And for re-renders, it's going to apply the minimal necessary operations, which happens in the React commit change to the DOM. So once it knows the difference, okay, once it calculate is, React will calculate which of the properties, if any, has changed since the previous render. Exactly. So once it calculates is what has changed, it won't do anything in the rendering phase. It will do that in the commit phase to apply now the minimal necessary operations calculated while rendering to make the DOM match the latest rendering output and the epilogue. So once the DOM detect, or once the browser detects those DOM change, the browser will repaint. After rendering is done, React update the DOM. The browser will repaint the screen. Although this process is known as browser rendering, we'll refrain it as painting to avoid confusion throughout the docs. So car is being called. Car now processing run execution function here. And then now is send it to the commit to be appended to the DOM. Okay. So as we look now in the next one, which is asynchronous updates, right? All right, time to cover our first state base food gun. A food gun is part of the library framework that tends to cause problems for the developers, since they inadvertently shoot themselves in the foot trying to use it. Consider the following code. What value will you expect to see in the developer console when the user click the button for the first time? On the first time, okay, since this is the evaluation, 0 is going to be assigned here as the count, and they say you click 0 times here, and because here we got is the button, this will gonna convert to a React fragment with children as a P in this content, and follow with this React elements with the children as the bottom with the type of bottom, and the props on click, right? Where this is the function that is going to be executed, right? Is not going to execute this function initially. It's a good question. It's a good question. And they now show the click here. When the user clicks the button for the first time, what will be is a console log. When the user clicks the button for the first time, what value would you expect? What value would you expect to see in the developer console when the user click the button for the first time? Well, if they click now the button for the first time, right? This calling the set count would say, hey, whatever value you have here, which is count plus 1, it'll be now 1, okay? And since this function happening is at React, and we don't know what happened before and what is the returning value of this set count, all right? So somehow we need to, yeah, it's like somehow, well, I do know what is going on here. So by the time that we call this, which is calling internally this function, and by the time that this function is done executed, all right, we might think that the value of count is 1. But it turns out that since this set count is going to notify React to detect that that a change happens here at this component, all right, and the count value when we click here, it'll be 0, because all after the DOM has been updated, all right. Okay, so after this function has been evaluated, and this is interesting because I don't know how to explain that. Let me do this. So what will be the value of count? The value of count will be now 0. Why? Because by the time that we call this function, and when that function finish, okay, it doesn't automatically, or we can think of this, is 0. Pretty weird, right? When we create our state variable, we initialize it to 0. Then when we click the button, we increment it by 1. So shouldn't it log 1 and not 0? Here's the catch. State setters are immediate. That's what happened. So state setters are immediate. When we call set count, we tell React that we like to request a change to a state variable. React doesn't immediately drop everything. It waits until the current operation is completed, processing the click, and then it updates the value and triggers a re-render. For now, the important thing to know is that updating a state variable is asynchronous. It affects what the state will be for the next render. If I update it, and now it makes a lot of sense. What we talk about is that what we talk about is that updating in a state is asynchronous. It makes a lot of sense. It makes a lot of sense. Okay. Because we know how JavaScript's working. For now, the important thing to know is that updating a state variable is asynchronous. It affects what the state will be for the next render. It is a schedule updated. Exactly. So hey, I'm going to schedule this update. It's not gonna be immediately. It's not immediate. Okay, exactly. It's not immediate, and therefore it'll be on the next call. Okay, it affects what the state will be for the next render. It is a scheduled update. Here is how to fix the code so that we have access to the newer values right away. Mhm. Here is how to fix the code so that we have access to the newer value right away. Mhm. Exactly, you update that and then you pass down to the updated. Instead of passing that expression directly into a state setter function, set count plus one, we are saying exactly, instead of passing that expression directly, we're saving it by storing in a variable, and we can then use the variable in our console log statement or anywhere else inside this onClick handler. I like to use the prefix next, like the next count or next user, since it conveys to what we're talking about the future value of the state. That will be on the next render. Ultimately, though, that's just my own personal preference. You can name these variables whatever you like. Why does it work this way? That it given that this is such a common stumble block, it is worth asking why it is set up this way. Wouldn't it be simpler if React update the state variable right away? Let's think about it. Um, mm, why does it work this way? Given that is such a common stumbling block, it is worth asking why it is set up this way. It wouldn't be simpler if React update the state variable right away? Let's talk about it. Well, if you think about this, if you think about is how this will going to be, right? So somehow the React needs to is uh, update the DOM nodes, and it is all about is when the when the reconciliation phase happens, or it is all about at which point do you want to reconciliate the DOM? At which point you want to this two different snapshot uh, have the value, and it turns out that it will be logical to that new state will be available on the next snapshot, not in the current one, but on the next one.
In order to understand why the React team chose to make the state updating process asynchronous, I think it's helpful to look at an example with multiple state variables. In this scenario, I have this big logout button, and when I click on the button, I'm going to change each of these state variables. Let's talk through exactly what happens and what the process is. When the user clicks on the button, we're going to call this callback function, right? The click event triggers. And the first thing we're doing is we're calling the setUser function and passing a value of null. React says, okay, I see that you want to change the user state variable from the current object that it is to this new value, but it doesn't do it right away. It makes a note to itself, essentially assigning itself a metaphorical Jira ticket that says, at some point soon, I'm going to have to rerun this code, but now user is going to have a new value. Then we keep going with our click handler function, and the next thing that happens is that we call setStatus. React says, oh, there's other things that have to change as well, and it edits the Jira ticket so that not only will the next update have a new value for user, it'll also have a new value for status. Finally, we have one more thing we have to do. We call setConfirmationMessage, and React makes another edit to the ticket, and now React is all set. We finish going through this click handler function, and React springs into action, triggering a re-render and doing all the stuff we talked about in the core React loop lesson. Essentially, it runs this function again, except now user is equal to null, status is equal to the string initial, and confirmation message is equal to this string over here. As a result, because we don't have a user anymore, we return a paragraph that includes this message. Now, let's imagine that state updates in React were synchronous. what would this flow look like? The user clicks the logout button, we call the click handler, we then call the set user function, giving it a value of null, and if state updates were synchronous, React would then immediately have to update the value. And so it would trigger a re-render going through all the steps we talked about in core React loop. User would now be set to null, but neither of the other state variables will have changed since we haven't gotten there yet. It would return a paragraph. React would play the find the differences game. It would remove the button. It
It's
would
because
add
the
a
batching
paragraph.
here.
And only then would it go back
It's
and
because
keep
the
going
batching.
through the click handler function. On the very next line, we would change another state variable, so React would have to do the whole
Is
song and dance
batching
again.
state
And
update.
essentially, we
That's
would
what is
force
this-
React to do
that's
the
what is
entire flow
asynchronous
back
update.
to back to back for each of these three variables. Not only would this be bad for performance, like it would take 3 times as long to get through this update, but it would also lead to an inconsistent UI. Like, let's imagine that we re-render with user being null, but not changing these other state variables. Well, we'd wind up with a blank screen because user will be null, and so this condition will be met and will return a paragraph. But we haven't changed confirmation message yet. It's still undefined. And so, even though it would only be for a very brief moment, we would be showing the user the wrong UI. Because updates in React are asynchronous, it's able to batch multiple updates like this. It's able to wait until whatever we're doing has completed, rather than interrupting itself mid-click handler and going through the whole flow again. And so, while it definitely does cause a lot of confusion, especially when you're just getting started with React, ultimately, when we consider the alternative, I do think that the React team made the right call.
Yeah. And then now exploring about the exercise here. Bastion and Basilisk bug. You're building an in-browser role-playing game, Bastions and Basilisk. You have hit a snag. The wrong values are being shown to the user when the characters level up. Your mission is to fix the bug. Congratulations, your hero has now the following stats: Strength 6, Dexterity 2, and Intelligence 3. Oh, Okay. Okay. So when the level up button is clicked, the alert that pop up should show the update value for strength, dexterity, and intelligence. For example, when clicking the button for the first time, strength should be displayed 7 and not 6. So one way to fix this, alright, is by calling this new state. Say next or new strength, newest strength, it'll be this expression. New strength will be this expression, and this is what we're going to pass to this. The same for dexterity. That'll be is here we can define this as cons. All right, new dexterity as this, and the same for intelligence, right? Where the name will be is new intelligence. It's this one and this one. And this is what we're going to actually show this. And it makes a lot of sense for us to say, hey, you know what? The batching state updates are asynchronous, and it makes a lot of sense because if you do have, for example, multiple of this state at that handler, Uh, so React will have to rerun this per each one of those state updates, which makes not a good idea. So what you're doing is just like raising a Jira ticket here. So once we do this, we are now be able to look at that properly. Alright, so when we reload this, there's no error here. We level up, we get this and showing that as it is.
So I won't sugarcoat it. There are certain things with the way state has been designed in React that can be really confusing and unintuitive, and it leads to the frustrating situations like the bug we are dealing with here. We have our little wizard character. The wizard has these different attributes. When I click the button, it calls this function, which increases all of those attributes, right? We're leveling up. And then we want to show the user the good news. We want to show them what their new attributes are. But as I'm sure you've discovered, when I click the button, strength is still sitting at 6, dexterity still at 9. These are the initial values. These aren't the updated values that we see over here. And perhaps even more confusingly, if I click it again, well, now they are higher, right? It went from 6 to 7 instead of from 7 to 8. If we just focus on strength, because too many numbers otherwise, every time I click on this, it's going in the right direction, but I'm seeing stale values, right? I'm seeing what they were last time, not what they should be now. And the key to understanding what's happening here is to realize that these functions don't quite work the way we often assume. It's not actually changing the value of this variable in this context, right? We tend to think of it as like the equivalent of doing this, like strength equals strength plus 1, but that's not quite right. The way these functions work is they schedule an update. So it's a way of telling React, hey, we're changing some stuff. We want strength to be this new value. We want it to be increased by 1. So can you please re-render with these new values, right? We're telling React that it has to redo all of the work that it's already done to figure out what the UI is. But on that next pass, it should use these larger values. What that means is that the program looks at this line, makes a calendar appointment for itself, right? As soon as it can, it's going to do this stuff. But it doesn't interrupt what it's already doing, right? It's in the middle of doing something, which is running through this function. So it's going to go through the rest of this stuff without changing anything. All it's done is it's added a little calendar appointment for itself that once we finish with this work, we will re-render. And when we do that, right, when the next time we declare this line, the next time this line runs, strength will be populated to the new value of 7. I know that's a lot of words, and it can be hard to follow. So let's actually do some console logging. I'm going to say in level up, and we're going to look at the value of strength. And of course, it works the same for all 3 attributes, but to keep things simple, we're just going to focus on strength. I'm also going to add a log to the main function body, and I'm going to say in render, so that we can see what this value is at this moment as well. So when I do this, and if I refresh this little window over here, well, right away we see in render 6. And this is good, right? It means that when we first render the component, which we need to do to get this UI rendered, we see, aha, we have this initial value of 6, and that's what it shows. When I click the level up function, we get our alert, right? It started working through the trigger level up function. It still shows as 6, which makes sense because we haven't changed it yet. But notice what happens the moment I press OK. And it's really quick, right? You blink and you miss it. I click OK, and right away it says in render 7. So what these functions do is they schedule an update, and when that update happens, it'll provide these variables over here with their new value, right? In render number 2, where all of this stuff is redone, it's going to take this new value. But as long as we're still in render number 1, which we are until this work finishes, these variables are unchanged. If that still doesn't make sense, I apologize. It is really hard to understand. This is just one of those things with React that takes a while to get used to, so don't worry about it. As we get more and more practice with this stuff, I'm sure it'll sink in. But we haven't figured out how to solve our problem yet, which is how do I show the user the new values right away? You might think, well, maybe I can wait until later, right? Like show the alert on the next render. You could do that, but there is an easier way, which is how about I declare a new variable called next strength, use that variable over here, and then we can use the is the right value. It hadn't reloaded since the last time. So because we have the value available to us, hey, I see the new values right away.
Counter 2.0. And this is another exercise. The counter 2.0. The counter has been upgraded and now supports several functions. The buttons have already been added to the page, but they don't do anything. Your job is to wire up the button. Accepted criteria. The button should increase by the count. Increase the count by 1. Increase the count by 10. Reset to 0. You should set the set count to a random number between 1 and 100. Should decrease by the count of 10 and should decrease by the count of 1. So let's get into this. So here we can is define. So the point here is that we're going to define is several of these functions, okay, per each one of those handlers. And here we're gonna say increase by 1, increase by 10, decrease by 1 and decrease by 10, reset to 0. You know, being descriptive in each one of them, you know. And similar for the hash, right? You say random, generate random from 1 to 100, you know, so I don't have to compute to calculate that. So let's get into this. So it's going to define is a functions here to say increment by 1, right? And here this is a function that is going to say this, all right, and set count of count plus 1, all right. So it's gonna update the value of count at that moment. We're gonna do the same. We're gonna now do this for that and add it to the this, increases slightly. And it's interesting because again it's continuously using is this visually hidden. It's continuously using that. So on click for accessibility. So here we're gonna call this increment by 1, and we're passing this as a reference as a function, right? So this is the function we want you to call here. And as you can see, this will work. So we can do is the same for the increment by 10, say 10, increment by 10, and then you say decrement by 1, and calling this decrement by 1. The same for decrement by 10, right? I'm just gonna stick with this. And also is reset, where here we're gonna reset to 0. All right, so reset to 0, right? And let's get at least to attach each one of them, right? Say, yeah, 1, increment by 1. This is another button to say on click. And then you're gonna pass this increment by 10. We're gonna replicate this similar behavior for this another one. to reset to 0. I prefer to be very descriptive when I do this. This is the hash to generate random number. And here is to say to decrease, so decrease by 10, right? Say decrease by 10. You got this. The other is decrease by 10. Decrement. Decrement by 10. And here you say is decrement by 1, right? So all of this will work. Similar for this. And you got 8. Funny behavior there. Okay. That's interesting. Yeah, but exactly. Yeah. It is 10. Yeah, you got it. Okay. And there you go. And this will be printing 8. And there you go. Now, let's go to generate is this random number here. Say const random number. Or generate random 1 to 100. You know, be very specific here. So here we're gonna say, hey, I do wanna generate is this random number by saying set count here 0 and say something like this. So mat floor of this number that we're gonna use, but we need to use is crypto. So get random values here. All right. So it has now an array type. And yeah, you get it. So get random values. Exactly, random UUID. This is to generate is that, but this is to generate is now this. So if we do want to generate random numbers like this, we can say is this to say generate a new array of that. To say new integer of 32 array of, let's say, 100. All right, which is 100 elements that we want to generate randomly, and then call the crypto dot get random values and assign that value, right? So we already generate all of this random numbers here. If you do want to say, hey, numbers from the range to 0 to 1, we have to say here is this. Let's gonna ask claw to generate random numbers from 1 to 100 in JavaScript. Might be quite silly, but it is important too. All of them are using mat random. Let's go with crypto function more uniform distribution using uint array for small ranges. Exactly. Generate multiple sequence secure random numbers. Key advantage of crypto API: cryptography secure, suitable for password tokens, better entropy, use OS level randomness source, not predictable unlike math.random, which can be seeded. In all motor browsers like that. So the idea is to generate is this in a range, right? Mm-hmm. Exactly. It's help me to generate is one single number. Okay. Help me to generate is one single number. Here I can say something like this and say help me to generate is one single number. So this single number that I know that I need to pass here, okay, help me to generate is one single number. Okay, I want to generate is only one single random number, and I want to iterate, or I want to do this. Mm-hmm. Exactly, and I want to generate one more uniform distribution recommended, and I want to get one. All right. Secure custom random, get secure random int for smaller range int. But I do want to get is only one where the value that you give it to me, all right, if I get the mod of this range, it's gonna give it me is that. Okay. So in other words, if I do this, which is, hey, I want to get is one element, but the element that I want to get is between this range, which is one, which is between let's say you're gonna pass max, min, right? And if we don't provide any value for this, by default max will be 100 and min will be is 1. Okay, so we say, hey, I want to get is the max value minus the min, and add it plus 1. This is to actually get the range in which I want to generate this value. Once I do that, then I want to get the model of this range, and the model will give me is any value inside of the model. This is one of the mathematical trick that we can go with. Holy fuck. So here we're saying is I want you to return, right? I can say that. I can say is crypto get current get random values. Okay, get random values. Okay, exactly, get random values here, which is only 1. All right, so this random value that I'm gonna get, I want to is assign to the result, all right, and to say something like this. Hey, if the value that I'm getting from here, whatever value that I'm gonna get here, I want to return, or let's say random number. So I want to say is this. Result will be is the random numbers between that. Say random number. I want to get the mod. I want to get the mod of this, right? I want to get the mod of this. And then I want to only get is the, because at the end of the day this is an integer, that's what it is. So result, right? And then when I assign this, set to random values, you say on click. Let me now call that generate to random numbers. This is to reset. I do think that it prints some error here. On click, generate random 1, 2, 6. Oh, it's because I do need to is pass this as a function. Exactly. So in other words, I do need to pass this as a function known as inline function. All right, just like that. So I don't want to invoke that. Yes, I don't want to invoke that. And when we're wrong here, it's calling on the hash. It's supposed to return this value, the result of that. Let me see what actually is returning that from result. Oh, it's because we are not updating the state. And since we are not updating the state, well, we can just say something like this, which I do find this is quite relevant, right? We can call this and see what's print in the console. Interesting. Let's take a look at this. There you got it. So I'm calling this function. It's like nothing is happening here. It's like not even calling this function. That's why my bending. And then I can say generate. Call the generate random function, and then you get it, right? But that's interesting. Oh, exactly. It's because I'm not updating the state. And since I'm not updating the state, I can do is like so here. Exactly. I can do is like the set count is the result. Right. And now to set count. So to refresh this. and set count is this one, right? I can even close the range here, and it's going to guarantee a little bit less number to go with. But it's not updating the state. Set count with the result. All right. And it's not doing it, despite that we added here at the bottom generate random 1 to 100. I get it, and it's because no, it's because it's receiving is this max. Okay, now I get what happened. Yeah, I do know what's going on. So what I can say here is to well, not receiving any arguments here. In fact, define this as it is, right? Say max, max and min, right? And now it'll work, you know. And now it'll work. What's wrong here is that because we are calling that function in at the inline, React behind the scene is injecting is this a synthetic event as the first argument. That's what happened here. So if you don't believe it, no problem. I can show you here, which is the event, right? Which to me is quite interesting because at the end of the day, we are receiving is this value, and therefore is doing this as it is. So you can see here the first argument that we receive. If we go and choose to use this as this, right? And on the console, it's not this, but in the console, we're gonna see that it's going to receive that event. It's not running. Perhaps it's not able to print that out here. What about now? That's quite revealing. Because at the end of the day, that's what I want you to do. Calling this generate random numbers. Generate random numbers. I do not want to update the state. In fact, I want to check if I'm receiving is this value here in the console log, right? And I do receiving that current values is. But it turns out that so if we say something like this, all right, to pass this as a reference, all right, now we'll see what's going on. Exactly, is this, you know, that's the first parameter is actually receiving that event, all right, and then it's now calculating something that is not a spec. Well, it's calculating this properly because we do pass this. But yeah, this is how we can actually generate is random numbers here, and that's quite interesting. So what's going on here is that the crypto methods, it needs in a collection of elements to generate is random numbers in this range. And here, because we are telling that the range of those numbers is up to 255, and whatever value that you generate here will give us is a collection, which is only one. I want to give it to me is this number that is within this range, in the range of this. And then update that as it is. And as you can see, is this. With this playground make us a third-party dependency, React Feather, to provide the handy dandy icons with each button. This is my go-to icon package for React. And we'll see through the course. We're also using the visually hidden trick in the conditional rendering exercise, as you can see. And this visually hidden, it is, well, something that I can't have access to, but is doing that as it is.
So the basic counter from the lesson earlier is all grown up, and now this big boy counter has all these special buttons that we get.
Mm-hmm. Mm-hmm. Hmm. Mhm.
To implement. And I think it makes sense to start by sort of redoing what we already saw, which is the increase by one button. So on that button, I'm going to add an on-click handler. It's going to take an arrow function. And we need to do this because essentially we need to pass it a function reference. So when I click this button, it's going to call this function. And when we call this function, it's going to call the setCount state setter function. And we're going to say that it should be set to the current value plus 1. When I click on this button, hey, look at that. The number goes up. And I'm going to copy this, and we're going to kind of work symmetrically. So I'm going to go down to and change the amount. That we can change this value by leaps and bounds or by small amounts. Reset button. Use this variable in both of these places. That way, if we decide maybe it should be 123 as the initial value, when I refresh the page so that it uses that value, we see that it starts at 123. I can modify it from that point, and then I can reset it to that value. And if we really wanted to be fancy, we could make this a prop to our component with a default value. And actually, let's go back to 0. So that way, different counter instances could change what that initial value is.
Exactly. Counter different instances know what the initial value is.
And for the very last button, the randomize button, this one is a little bit trickier. Count, but what should it... We can't see because it's being cut off, but it's 0 point here. And I think it makes a next count, and I'm here, next count, and counts up. So even if our number is 0.01, this effectively gives us a random number from 0 to 100. Now, if we really want to be precise, there is a flaw with this, which is that math.random actually can produce the number 0. And if it's exactly 0, then it won't be rounded up to 1. It'll stay at 0, which isn't quite in our parameters. So this is like the most nitpicky thing in the world because the odds of it are astronomically low. But if we really want it to be precise, I'm going to grab this clamp function that I use. And it looks really complicated. Essentially, it uses math.max and math.min to clamp a given value between a given minimum and maximum. So what I'm going to do, just to be safe, is I'm going to say clamp this whole value with all of this stuff, and it's going to be clamped from 1 to 100. When I run it, it still seems to be doing the exact same thing, which is good news, right? I can see it go any number from 1 to 100, but it shouldn't ever exceed those bounds.
So why the dance?
So this is a meme that was circulating around JavaScript Twitter a few weeks ago. It features TikTok sensation Kabi Lame, and if you're not familiar with his videos, I highly recommend them. But the joke here is that you have all this fuss, right? All this ridiculous over-engineering to manage a state variable in React. And when you compare that to something like Svelte, that's what this little S logo is down here, where in Svelte you just have variables, and it feels so much more intuitive and obvious. And it does sort of beg the question, like, why do we need all this stuff? Like, why can't we have something simpler? So, in this video, I want to talk, and I think the best work. So I'm going to replace all of this fun stuff. It doesn't work, right? But why doesn't it work, right? Why can't we do it this way? Well, the first thing we run into is that JavaScript doesn't really give us a way to observe to rerun. And it doesn't possible. Like, you can't do this in JavaScript. And so what that means is that it's going to have to build something more complex. So you're not avoiding the complexity with Svelte. You're just kind of, you're putting a curtain in front of it. You're veiling the complexity, which can be good, but it can be bad as well. Okay, but you might be thinking, okay, well, I need to tell React to re-render. So let's say that we have like a magic wand and we can just add whatever APIs we want to React. Why don't we add a react.re-render method? And the idea is the developer would call this method whenever they want React to re-render. So we create a variable count, we increment it by 1, and then we tell React, hey, it's time to re-render. Well, this also doesn't work. And it's a little bit complicated. We're going to have to let's say I have a function, a script, and component that on the very first render, we're giving React the value and then plucking it out into this count variable. But on the second render, we're reaching in and grabbing the new value. And on every subsequent render, that's how this works, right? We're plucking the value from inside React, which exists outside the scope of this function. In terms of why we also have a setCount function and we can't simply
But now we do actually understand what's going on here. But from this point on, I am quite familiar with all of this. So that'll be all for this video. Take care. Bye bye.